And we are going to do more fraction basics. Okay. So let's do another word problem. Quiz Friday is going to be about these word problems. So in this problem, we'll say Peter had 400 stamps. Five-eighths of them were Singapore stamps. And the rest were US stamps. He gave 1/5 of the Singapore stamps to a friend. How many stamps did he have left? Okay, so Peter had 400 stamps. 5/8 of those stamps were Singapore stamps. The rest were US stamps. He gave 1/5 of the Singapore stamps to a friend. How many stamps did he have left? Okay. So let's kind of strategize a little bit. Let's think about it before we even draw the diagram, okay? Think about what we need to do before we draw the diagram so that we can draw a diagram that illustrates the steps. Okay, so what do I have to find? What do I have to figure out before I can answer the question at the end, right? We got to work kind of backwards. At the end, I'm supposed to figure out how many total stamps are left, right? But what do I need to answer before that? Okay, right, we should answer how many Singapore stamps does he have, okay, because we know he gave away 1/5 of those, okay, but we can't figure out how many he gave away until we figure out how many he started with. Okay, so in our bar diagram, we should do something like this. I've got my bar, and this bar is going to represent the 400 total stamps. Okay. So how many units should I break this bar into?
8.
8, okay. And how do we know that?
Because it talks about him
All
having
right, 5/8.
5/8.
I'm looking at this fraction. I see 5/8 of the total stamps were Singapore stamps. So we should take that bar and break it up into 1, 2, 3, 4, 5, 6, 7, 8. Okay. So these are the Singapore stamps right here. 1, 2, 3, 4, 5. I shade 5 of my boxes. Those are the Singapore stamps. Okay. So I should start doing some computations over here. What computations should I be putting down here?
Five-eighths minus 1/5.
Okay. Yeah, I see why we might think that. I'm not sure that really helps us though. Let's think about the computations we did in the last one. I had something like units and stamps. So how many units equals how many stamps? That's probably where I should start.
8 units equals 400 stamps.
Okay, so 8 units equals 400 stamps. Okay. So that means each unit equals how many stamps? 50, right, great. So 1 unit equals 50 stamps. Okay. Now this is actually kind of neat. Notice how many boxes are devoted to the Singapore stamps? 5 boxes. Does that help? Okay, so we could figure out how many Singapore stamps he has, right? How many does he have? 250 of the stamps are Singapore stamps. Okay. Now, what would we do with the 250? Okay, we could make another bar graph. And how many pieces would we break that up into?
5.
5 pieces. Okay, but let's look at the bar graph we have. My Singapore stamps, how many pieces is it divided into? 1, 2, 3, 4, 5 pieces. Okay, so we probably don't even need to make another bar graph, right? Okay, let's just say, okay, these are his Singapore stamps. We know it was 250 Singapore stamps. He gave away 1/5 of them. Let's just say he X's out. That's the 1/5 that he gave away. So how many units do we really need to worry about? We need to worry about the other 7 units in this bar diagram, because that's what he's going to have left. So if 1 unit is 50, then 7 units must be 350 stamps. So Peter has 350 stamps left, okay? So it's probably the most efficient way to do the problem there, okay? And the reason you want to do those things as efficiently as possible is because the more computations you introduce, the greater the chance of making a mistake, okay? If you only have to do 2 steps, well, you only need to get through 2 steps. If your process for solving the problem is 12 steps, every step is another chance to make a mistake. So you want to reduce the number of steps needed. Okay. So I want you to think back to the teaching sequence that we had discussed last class. Okay, we had some Roman numerals in there. And this is also part of the book, I think, or it's also in the book. But where did we leave off in our teaching sequence? What did we cover?
Renaming fractions.
Okay, so we had renaming fractions, and that was things like if you want to go from 1/2, how many fourths is that? 1/2 equals blank over 4. Things like that. Now, in the notes that I posted in the module, I believe there's a couple of extra components in there. Okay? So renaming fractions, what number was that? It was Roman numeral 3. Okay? In the notes that I posted to the module, I got a couple of other stages in there. So make sure you go on to Canvas, check that module, and look at those notes. Because we're going to continue our teaching sequence here. And we are actually talking about Roman numeral 6 in the teaching sequence, right? So you got 4 and 5 there in the modules. Make sure you check those out. Okay, so number 6, now this is stuff that starts to get introduced grades 4 and 5. So remember, fractions get introduced informally in the primary grades. We're talking about grades 1 and 2. Starting around grade 3, students are starting to be expected to work with fractions, at least certain kinds of fractions. Once you hit grade 4, you're talking about working with improper fractions and mixed numbers. Okay, what is an improper fraction?
Where the numerator is bigger than the denominator.
Right, the top number is bigger, the numerator is bigger. Okay, so a couple of definitions here. Improper fraction. The numerator is larger than the denominator. Okay, so for example, stuff like 17 over 4, that's an improper fraction. 112 over 7, that's an improper fraction. A mixed number is a whole number plus a fraction. Now, both improper fractions and mixed numbers are used for the same purpose, okay? They're used to represent quantities bigger than 1. If you have a proper fraction where the numerator is smaller than the denominator, then that fraction has to be less than 1, okay? But obviously not everything is less than 1. So mixed numbers, and here I'm typically talking about something like this, 2 1/8, 7 3/5, okay? And remember, there is an implied, okay, that is 2 plus 1/8. Okay, so it's this whole number plus this fractional part. You can't take the 2 and cancel it with the 1/8 and get 1/4 here, okay? And that other one is 7 plus 3/5. Okay, so these are typically easier to understand, figure out where that number lives. So the mixed numbers are good for understanding the ordering of things. Improper fractions are better for calculation. This is better for calculation. The mixed numbers are better for comparisons. Okay, and in the teaching sequence, we need to connect improper fractions to mixed numbers. Okay, so let's look at a quick example here. Let me look at this improper fraction. (15 over 4). Okay, now you guys probably already know how to do this, but remember, as a teacher, you've got to break things down, okay? You can't rely on a student in your class already knowing how to do this. Okay, but just for practice, what do? How do I write the equivalent mixed number? Okay, right. So 4 goes into 15. We're thinking 4 into 15, it goes 3 times. So that would be the whole number part. And okay. Right, okay. So 4 goes into 15 3 times, that's the quotient. And the remainder is 3, there's 3 left over. Okay, so 3 3/4. Okay. Now, if you were to maybe start introducing this concept here. Let me think about this, right? We're thinking about 15/4. Now remember how we introduced the concept of fourths. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so this is 0 here. What's this? That's 1, okay? Now how do you know that's 1? Why isn't this 1? Why don't we start right there? Right, we're dealing with fourths, okay? So when we're dealing with fourths, we want to cut things up into 4 pieces, okay? So we want to cut our segment from 0 to 1 into 4 equal pieces, 1, 2, 3, 4. 1, 2, 3, 4. Now where am I? I'm at 2. 1, 2, 3, 4. I'm at 3. 1, 2, 3, 4. Here I'm at 4. I probably don't need to go that far. Okay, but if I were to count 15/4, just like this says, 15 of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, that's 15/4 right there. And we can see 15/4 is living between 3 and 4. Right? It's 3 plus 1, 2, 3 additional fourths to get to 15/4. Okay? Another way to think of it might be like this, right? To get to 15/4, you have to do 4 over 4, another 4 over 4, yet another 4 over 4, and then an additional 3 over 4. Because that gets you 1, 2, 3. Now you can't go another whole number jump because you pass it, okay? So you have to do 1, 2, 3 jumps of a quarter, okay? So there's a reason that we do that division, okay? To get the whole number part, we need to know how many full steps we can take, how many 1 unit length steps we can take. So we divide by that denominator. We can see we can take 1, 2, 3 of them, and then there's 3 additional ones. Okay. Another way, another kind of model for changing between mixed numbers and improper fractions. So let's say I had this mixed number. 4 2/3 equals blank over 3. Okay, so how do we do this? Think about what you already know and do the calculation. Write that as an improper fraction. Somebody in Zoom land, help me remember. I want to take this mixed number and I want to write the equivalent improper fraction.
You take 4 times 3, and I believe
Right.
you just add 2.
Okay, so we take, start with this 3, multiply by the 4, and then add 2. Okay, 3 times 4 is 12, plus the 2 is 14/3. Okay, so kind of maybe as a reminder here, 14 2/3. We would multiply those, and then we would add that. Okay, but let's think about what it is we're doing. Okay, so 1, 2, 3, 4, 5. Okay, so what does that picture represent with the circles and this last thing? What does that show? 4 2/3, right? I've got 4 circles shaded entirely, and then I've got this one additional circle that is broken up into 3 segments, 2 of which are shaded. So that's 1, 2, 3, 4, and then 2/3. Well, think about when we were dealing with our word problems, right? We had a denominator of 3. Break things up into 3 pieces. Break your circles up into 3 pieces. Okay, so now do you see why we do the 3 times 4? Why are we doing that? What is it telling us?
Because when you split it into 3 pieces, you're saying that 3/3 is 1, and when you add 3 4 times, you get 12, and then 2 out of 3 would add 2 more on.
Okay, right. So we are basically, when we're doing that, we're kind of counting the number of slices that we have. If we have all the circles divided into thirds, right? Because we're talking about thirds. So we're saying 4 2/3, and you remember how I wrote this at the beginning? 4 2/3 equals blank over 3. 4 2/3 is how many thirds? Well, each of the pieces of the whole number gives me 3 pieces, and there's 4 of them. Okay, so 4 times 3 plus the 2 additional pieces over here. Okay, so it's important to kind of make that connection with your students there. Okay. Another step in the teaching sequence is the idea of fractions arising from the operation of division. Okay, fractions from division. Okay, this is a good time to introduce things with word problems. Okay, so let's say we have 7 children and there are 4 cookies that they want to split between them. So 7 children want to split 4 cookies. How many should each child get? Okay, so a couple things to think about. When we're thinking about this problem, it's got to be less than 1. How do I know the answer's got to be less than 1? Right, 7 kids and only 4 cookies. So if you start by giving the first kid 1 cookie, and you give the second kid 1 cookie, and you give well, you run out by the time you reach the 4th kid, and now the last 3 don't have anything. Okay, so we're going to have to cut these cookies into pieces. Okay, so what should I do here? How many pieces should I cut the cookies into? Let me draw 4 cookies. Just circles like I had a second ago. 1, 2, 3, 4. Okay, what should I do? Okay, cut them in half. That might help. Now there's 8 cookies, or 8 halves. I could give each kid half a cookie, but then we have a leftover. Is there any way we could distribute it so that there isn't any leftover? Right, cut each cookie into 7 pieces. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so I cut each cookie into 7 pieces. Okay, that gives me 28 segments. Okay, 4 cookies equals 28 sections. So how many should each kid get? How many sections should each kid get? Right, each kid should get 4 of those sections, right? Okay, so if I take 4 cookies divided into 7 pieces, 4/7 of a cookie. Okay, right? Remember, when we were talking about introducing fractions, we talked about counting fractions. Each of these sections is 1/7. And we just said each kid should get 4 of these sections. 1/7, 2/7, 3/7, 4/7 of a cookie. Okay, so fractions actually arise quite naturally in the case of division. Okay, we actually need to be able to move between these different representations. Okay, so here's another fraction rule. A divided by B is equal to this fraction, A over B. Okay, so if I had something like this, if I had 17/3, that's equivalent to 17 divided by 3, which is, of course, equivalent to this right here. Okay. Five, remainder 2, right? Now, this calculation I just did actually shows me what the equivalent mixed number should be. What's the mixed number of 17/3? All right, 5 2/3. We just did the math right there. 3 goes into 17 5 times with 2 left over. 5 2/3. Okay, so all these things are equal, are equivalent. Okay, so that's something we need to get the students to work on when they're in this teaching sequence. So like I said, this is something we're talking around grade 4, so you'll need to be proficient in this. Even if you end up teaching a grade that is before grade 4, you need to know what's coming up so that you can get the students to the stage where they're ready to do this right here. Okay, so I'm going to post some material to Canvas about adding unlike denominators and common mistakes. Okay, so make sure you check on Canvas for some 6.2 stuff. So before next class, I want you to read section 6.2. Okay, hopefully you've already read 6.1. Read section 6.2 and do the homework on, okay, do the homework